KNNs means K nearest neighbor. So give me a minute for that. So anyone have idea what is KNN, guys? Anyone have idea what is KNN? Anyone have idea what is KNN?
KNN is not.
Yes, K nearest neighbor. So good morning. Now we have to see the K nearest neighbors. Okay. So what is K nearest neighbor? The K nearest neighbor is a supervised learning algorithm used for both classification and regression problems. Okay. So it is a lazy learning regression problem. So it is a lazy learning algorithm, means it does not explicitly learn a model during the training, but instead of that, it memorizes the entire data set and makes the prediction based on the similarity of the new data points to existing ones. Okay, so this is the K nearest. So it is an KNN is a supervised learning model used for both classification and regression. Okay, so it is a lazy learning algorithm, means it does not explicitly learn a model during the training, but instead of memorize the entire data set and make the prediction based on the similarity of new data points. Okay, so how KNN works? So how KNN work is, so KNN work, it choose the number of neighbors. It choose the number of neighbors like capital A. So K is a user defined. Okay, so K is a user defined. So K is a user defined in this. So user defined constant, the determine how many nearest point will be considered for classification or regression. So let's compute the distance of that. So the distance calculation is the distance between the new data point and existing all points in the data set is calculated. The most common distance metric used is Euclidean. Okay, we most common use is Euclidean distance. But other like there are so many distance, but we go for the only Euclidean distance. Euclidean distance formula is there. We don't go for that formula. Let's move to uh, so we have to find the nearest, we have to find the K nearest neighbor. So for that we have to select the K points that have a smaller distance from the new data point. So we have to select the K value which is very it is very small distance between the point. So we have to select that K value, K point. Then we have to make the prediction, like there are two types of prediction we able to do. The first one is classification, and for regression also we able to do. So the for classification, the new data point is assigned to the most frequent class among the K nearest neighbor, like majority of votings. Okay, this come under the classification. And for regression, the prediction is the average of the K nearest neighbors. It gives the average of the K nearest neighbor values. So we use for the regression. So let's take an example for the KNN. Can anyone give the full form of the KNN? Anyone?
KNN is neighbor.
Yes, K nearest neighbor. So let's see the example for this. So here we write. So we have to see KNN for, mm, we have to see the, okay, so advantages of KNN. Okay, it is a simple and easy to understand. Work well with a small data set. It works well with the small data set. No training phase is there. Okay, and what are the disadvantages of KNN? So slow for large data. It is good for small, but there is a large data is there. It is very small to compute that. Okay, so required choosing an optimal k. We want to require the optimal k we have to use. So affect by irrelevant feature or noisy data. What is by noisy data? Like value are duplicates. Okay, and some values are missing. So in that case it will be affected. Okay, so this is the disadvantages of KNN. So let's go for the code of this one. So what we have here, we are working on the iris data set. So like there's a flower, we have to work on the iris, flower iris. Okay. So let's see. Here we are using the k nearest neighbor for the iris data set. So flower iris data set.
Sir, screen is not visible, sir.
Now it is visible. Now it is visible.
Yes, sir.
Yes,
Someone is
sir.
sharing. Someone is sharing the screen. No one is new member here now. Please don't share your screen. Okay. Otherwise, my screen is off automatically. So KNN for flower iris dataset. So here we write. So first of all, we have to import the sklearn library. Dot. We have to neighbors import kn, not kn neighbor graph, kn classifier. Then from sklearn dot model selection, we have to import test train split. Then from sklearn dot datasets, import iris, load iris we have to import. So here we add the data, we assign one variable to this load iris. Okay. So after that we have to split the data. So extrain, xtest, ytrain, ytest is there. Then here we write test train split we have to use. And after that here we write data we have to write. And after this here we write data dot target. We have to target the data. And test size 0.2 means 0.2 means test size
20%.
0. Yes, 20% of data is reserved for the testing phase. And why use random state? Why use random state 42? When we when we when number of time we execute this model, okay, so it will give the same value. That's why we use random state. So let's create a model for that. So we have to create a model. Yes. So here we create a model for the KNN. So here what we have to write, here we have to write K neighbor classifier. Then in this we have to write n neighbor 3. Okay, so like this we have to write. Why we use n neighbor 3 n underscore 3? Yesterday I tell you guys why we use this. It is used, why we use 3, we write 3 for 3 is the nearest neighbor for classifier. Okay, 3 nearest neighbor for the classifier. For that purpose we write n neighbors equals to 3. So then after this we have to fit the model dot fit. We have to fit this one in X train and Y train. We have to fit this data. So we have to predict this data. So prediction equals to at KNN dot model dot predict. Then here we have to predict the Y X test and Y test. We have to predict here. We have to predict. We have to do the prediction. Now we have to do the accuracy also. So for accuracy, here we write print. The accuracy is, so here we write accuracy. Here we have to write KNN model dot score, and here we write X test comma Y test. We have to write. So like this, we have to write this code for the iris of the flower classification. So let's see output what it will give. Why it gives an error? To positional is required for predict. Where we did wrong. Iris load iris views from test case from classifier also k neighbors classifier. Then data equals to load. Oh, where we forget to give the data comma data dot target. Yeah, everything is
Test comma predict, sir.
where KNN dot predict. Yes, here we have to write predict. We forget. Uh, Predict we have to use. Yes. Uh, in prediction. No, it is in prediction. Where we did. Okay. In prediction, we have to give the X test only. Okay, now it is correct. So let's see what it gives the 1% of accuracy. Okay, means 100% of accuracy is there in this code. So any doubt? I have to explain this code, or you understand this? So here we import, first we import the required libraries. Okay, like from sklearn we import the neighbors, then from sklearn we import the model. Okay, from sklearn we import the dataset for the load iris. Then we put that load iris into one variable. So after that we create an trend test split we have to do for the what we have to do is we have to convert data into test and trend set. So for that we use trend test split function. Then we use a test size 0.2, means 20% of data is reserved. Random state equals to 42 is used for the to uh, like the when we number of time we execute this code, it will give the same value. For that we use random state equals to 42. Then we create a model for KNN classifier. So then after that we use n underscore neighbors equals to 3 for the nearest three values of KNN. Then we fit that model into the train like x train and y train. We use that variables. Then we have to predict that model. So we write KNN model, KNN underscore model dot predict of x test. Okay, then we find the accuracy of that model. So we write KNN underscore model dot score. So in that we write x test comma y test. Okay, so it will give the output as 1. So let's see the what we have to see. So in the data set it contains the features. Okay, features means x. There are four numerical attributes are there, like sepal length, sepal width, and petal length and petal width. Okay, and label is y. Okay, label data is y. So there are three categories of flower is setosa, versicolor and virginica. Okay, so these are the categories of the flowers in their data set in iris data set. Okay, in this data there is x and y is present, like x is for the features and y for the labels. Then we add the data. In the train test split, we divide the data set like 80% of data in training and 20% of data is for testing. We preserve the 20% of data for the testing by using the test size equals to 0.2. Then after that, we do the prediction and then we evaluate that model. The what is the formula for the accuracy is correct prediction equals to total prediction. So it will give the 100% of accuracy. So this means the model correctly classified, okay, with 100% of the test sample. So any doubt in this, guys? Any doubt in this code? Guys, any doubt in this code? Anyone please ask. If you have any doubt, you can ask.
No, sir.
Okay, so next we have to see is new bias algorithm we have to see. So what is new bias algorithm? So no, Naive Bayes is a supervised learning algorithm based on the Naive Bayes theorem. So it is widely used for the classification tasks such as spam detection, sentiment analysis, and medical diagnosis. The algorithm is called Naive because it assumes that wait, all features, yeah. The algorithm is called as new because it assumes that all features are independent. Okay, there are all features are independent, so that's why we call as new. So which is rarely true in real world data, but it still work well in practice. Okay, it is not possible like all time features are independent, which is rarely true. Okay, in real world data. So what is Bayes theorem? So new bias is based on the Bayes theorem, which calculates the probability of the hypothesis given by prior knowledge. So how new bias works? So first of all, we have to calculate the prior probability of each classes from the training data set. We have to calculate the prior probabilities. Then we compute likelihood probabilities for each given features in a class. Then we use the Bayes theorem to compute the posterior probability of each class. Then we choose the class with the highest posterior probability. Okay, so there are three types of naive Bayes classifiers. The first one is Gaussian naive Bayes, then multinomial naive Bayes, and Bernoulli naive Bayes. So the Gaussian naive Bayes we use for continuous numerical data. It assumes the features allow on the normal distribution. Like the example we can take as a prediction whether a student will pass based on the exam score. So there is a multinomial also. So in multinomial naive Bayes, used for the discrete data. Wait. We use for the discrete data of often used for the test classification like spam detection or sentiment analysis. So the third one is Bernoulli. So third one is Bernoulli new bias. So based on the binary features, like example is taking the word appears in a document. Okay, for that we use for the Bernoulli. We go for the Bernoulli new bias. So let's see the explanation of the new bias code. So here we use the multinomial new bias algorithm to classify spam the email is spam or not spam based on their text content. Okay, so we have to use multinomial for the email is spam or not spam. Okay, so let's see the code for that. So here we have to use let's write here we write new bias algorithm for email email classification email classification is spam or not spam. Okay, so like this we have to write. So here we write, let's see the example of this. So we have to import from sklearn import there is a some. Okay, so from sklearn dot sklearn dot new bias import. What we have to import? We have to import multinomial nb from sklearn dot feature extraction dot text import vectorizer we have to import. Then from sklearn dot model selection import trend test split is the common in all, so we have to import the 10 test split also. So here we take some data set from the email like win a free iPhone now, then lowest price on laptop, meeting at 3 p.m. project deadline extended. Okay, so like this we write. This is the data set we got. Then here we give the label data. So let's see the label we take as an 0 comma 0 and is win a free iPhone. It is possible to win a free iPhone now if you got this mail. So it is a spam or not spam? According to you guys, it is a spam or not spam? Win a free iPhone if you got an mail. It's a spam. Lowest price on laptop. It is spam or not spam?
Spam, sir.
And meeting at 3 p.m. Meeting at 3 p.m. If I send you the mail, we have the class from at 3 p.m. So what you said, it's a spam or not spam?
Not spam.
Okay. So project deadline is increases. So it is a spam. It's a normal. Okay. Like project is deadline is increases. Okay. It extended. Okay. It is a normal. This two is a normal. Okay. So this is not a spam. Okay. So what we have to do? Array we did. Here we have to write one comma 1 0 0. So let's convert the text into the numerical feature. So how to do this one? For that we use, here we create one variable vectorizer. Vectorizer variable we have to create, and here we write count vectorizer. Like this we have to write, and here we create an one variable. So in this variable we write, we have to fit that vectorizer dot fit in email, not we transform. Okay, we transform this into the emails. So let's do the once again, we have to do the train test split. We have to use y test, y train. We have to write y train and y test. Okay. So here what we have to do is, here we have to write train test split, and then in that we write, then after this here we write labels. Test size is 0.5. Here we take 0.5. What is meant by 0. Text size equals to 0.5 means
50%.
yes, 50% of the data is reserved for the testing phase. Okay. So now we create a model for this, like take nb equals to, we create multinomial nb. So then we have to fit this nb dot, we have to fit this in xtrain and ytrain. Then we have to print the accuracy of this model. So this one is the accuracy is, so here we write nb score, nb score we have to write, and here we test the model x test and y test we have to write. So let's see what output it will give. Yeah, the accuracy is 0.5. Okay, means the 50% of the test case is corrected. Okay. Okay guys, any doubt? Since we have a small data set, the accuracy may vary. Here the accuracy may vary, but for this example, we can expect the 50% accuracy depend on the split. Okay, we got the 50% accuracy here. Okay, so what we do in this, we convert the text into numerical features, what it called as an bag of words model. Okay, then we split the data set into training and testing set. then we then what we do, then we train a multinomial naive Bayes model for spam classification. Then we evaluate the accuracy based on the test data. Okay guys, any doubt up to here? Any doubt up to here?
No, sir.
Anyone, any doubt in this two KNN and naive Bayes? Any doubt here?
No, sir.
Okay, so I will give you the this PPT and the document on this one. So go with that. Okay, okay.
Okay.
I will
Okay,
share
sir.
this PPT with you. Okay, and this code also.
Okay.
So go with that, and I take attendance at 12 o'clock. Okay.